Good morning. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, December 17th, 2021, Friday. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज दिनांक दिसंबर 17, 2021 सुबह के 3:45। It is 3:45 a.m. in morning and this is set Friday, and talk is regarding same subject, that is quality and safety. Quality, title of talk is as usual, civil field engineering, life, engineers, concrete specifications, quality, and of course you can say quality system that we name by AnnexSL, and of course contracts, representations by Red, Silver, White books, and of course engineering designs, construction, and engineering methods and contracts. I am particularly calling engineering contracts and disputes all interlinked. No contract can be free from either of these. No contract can be free from engineering, free from field, and free from engineers, and free from life. And you can see there can be nothing free from specifications, and quality is of course a part of integrated work. And then contract systems, nothing can be free from designs, and of course what you can say construction includes all these. Of course it follows with methods and what type of contracts there are, and of course if contracts do exist, this and of course these are certifications that you know tell something about what person is. This can be for persons competency, that you can call it certification of competency or competency certificate. For example, this international professional engineer certificate, there can be professional engineer certificate, and there can be chartered engineer certificate, or there can be chartered engineer, or you can say competent engineer, or you can say licensed, whatever you can call it, a person who has got proven competency. And this is corporate membership, this is fellow certificate, this is one of three classes of membership, that is associate member, member, and fellow. This is, you can say, file that talks of quality, and I have put quality with cover of communication and coordination, because these are very important. Without communication and coordination, engineering cannot move, profession cannot move, and of course it's not only for engineering profession, but also it applies to all other professions, and even to those who do not work in professions but work otherwise. Communication and coordination, you can say, are like breathing in any profession. You have to respire, you have to depend upon this. Written document is an essential requirement, we may say, because without writing we cannot do any reference, we cannot memorize, we cannot remember every problem, we cannot remember every answer. So we have to document, and document is very important part of profession. Without this, you can say document is defined in law. I am not confined by that definition, but documentation is a must, and we cannot go without document. Document not necessarily be written, it can be nowadays sorry, it can be nowadays documentary, it can be video, it can be posting, it can be webinar, or whatever you can say, it can be some book, or it can be some reference, whatever. Only mobile would not work. Mobile is just a term. Though it is reliable, it's very efficient. I cannot deny this fact. But this cannot do everything in profession. This can only talk instantly and nothing else. Whatever you talked, you must record somewhere, or else that talk goes into vain. So we have to think of whose responsibility is in profession for quality purpose. Who is responsible to achieve quality in works? I can simply say responsibility of design lies on engineers, responsibility of construction lies on engineers, responsibility of manufacturing lies on engineers. There is nothing that can be done where technique is involved. I am saying technique is involved, otherwise no. Engineers are required for technical implementation, technique implementation, because that is scientific, that is procedure, that is mechanism. We evolve mechanism by innovating technologies. It all depends on physics, chemistry, or other subjects. We cannot go otherwise, and mathematics is, you can say, anatomy of all subjects. And mathematics is scientific, and mathematics is used in engineering from one step to unknown number of steps or infinity. Mathematics is science. It's a super science, you can say, and engineers do mathematics throughout study. And design is based on mathematics because theory of structure is based on various formula. And even you can say quantification, if you do, it is on mathematics. There is nothing in engineering, whatever branch of engineering you can think of, there is nothing in engineering which does not depend on mathematics, and mathematics considers engineering science, engineering basics, engineering foundation. When we do calculate analysis, we do calculate forces on members of structure, you know what I'm talking of. In that structure, analysis is done. What force has to come onto each member is calculated. Each member, what type of forces would come onto that, these are calculated. And based on those assumptions or based on the results, you can say, we make a balance. We make a balance on forces on that structure in various stages of actions or loadings. And then we can say, okay, now we can design this. And that design also depends on mathematical formula which we use. So you can say mathematics is a kind of total application of engineering, or you can say total application of engineering depends on total use of mathematics, whatever you say. This means it's a kind of direction, it's a kind of specification. And therefore you can say it's the responsibility of design specification. Design is specifying, design use, design description. Engineer to include demanded technical activity. Engineer cannot do without that. If one claims that one is an engineer, then one is understood to have worked on designs. When one is complete engineer, complete academical qualified engineer. Academical, I mean to say one should have complete degree, and that is called first degree. And engineering, of course, first engineering, and before that there is one diploma also. Diploma is, you can say, kind of 70% engineer. Then you can say academical engineer means, academical means once a qualified first degree, that we call in our country Bachelor of Engineering, or in some countries we call it Bachelor of Science in Engineering, and we can also say Technological Bachelor, B.Tech. So that person is required to know complete work, of course, to you can say constraints, of course, you cannot say everything, but one can move in engineering based on capacity of theory and designs, based on knowledge of how to implement works. Not expert, but one can understand. An assignment is given, or one can associate with someone else who knows everything. So it means quality is a part of engineering. Safety is a part of engineering, or you can say planning is a part of engineering, design is a part of engineering, construction is a part of engineering, and of course, commerce. Commerce in the sense of tenders, in bids, in cost. It's not commerce of ordinary type. It is technological based commerce, means where something is done forever, permanently. It's different kind of product when we talk of engineering product, and particularly products which work, which serve humanity for many decades to come. It's not an ordinary product. It's not vegetable. It's not kulcha chola. It's not tea or coffee. It is something that is house for you forever. House means not residential house, every kind of house. Every institutional house, health house, hotel house, residential house, road house, where you want to use for your livings. It's big and big, you can say super big. Maybe people don't realize it, and maybe even engineers don't realize it. If you construct a flyover, or if you construct a dam, or if you construct a road, it's not for one day or 1 month. You must have seen dams, you must have seen buildings, you must have seen bridges, which have been there for many decades, and they have been working successfully. And that's what we require. It should work more than we expected, and that is what you can say durability it is called. We call durability means it should give expected performance. It should give intended performance, what we expected of these materials. These are all engineering materials, not raw materials, but usable materials. Or you can say when you deliver buildings and structures likewise, these are kind of artificial engineered products. Means we can use them according to our understanding. We have to keep in mind we are not doing ordinary work. We are doing work that impacts on life of human being all over the world. And that's why I stress on issue of quality. Quality which can be defined in a number of ways. There is no set definition. It depends on your smartness, what way you want quality, and you can understand that only when you yourself have quality. When person has itself quality, person can understand what is quality. Quality cannot be defined by someone. There is no formula to define that. And of course, engineers are involved in that. Quality is something, it is different because quality of every activity is different. But quality exists. This term is very highly required. We cannot simply measure it in terms of quantity, and quantity and quality must be equal. But what happens? Quality lags behind. Quality lags behind and quantity moves ahead. That should not happen. And in particular, construction work, in particular permanent work, it's very important issue. Because if you spoil quality, we don't achieve quality, means you have destroyed that material, we have destroyed that structure is on risk. Maybe we say, oh, we done quality work. Yeah, we may say that, but we know it is not quality work. A person who uses it, he doesn't know it is quality work. That person looks only finishes. That person cares only for finishes. How is plastered, how is rendering, how is painting, how beautiful it looks. But that person does not know about structural strength, structural requirements, structural adequacy, structural durability, because that person is unknown about that. And who can teach it? No one. When there happens some accident, structure collapses, they may curse, they may say, oh, this engineer was bad, corrupt, this and that. Though there may be engineer, they may not be engineer on that product, but they may say, engineer was bad, corrupt, he might have taken money. Means what I'm saying, we have to understand people's responses. People can respond better in medical world, but they cannot respond in engineering world because of unawareness of, you can say, concept of whatever service is required, quantification, calculations that remain off of view, and how that engineer, that we can say professional, what level of education has got in, and from which institution that engineer got education, and what level of concentration to achieve quality. Quality can never be achieved. That is very engineer, and dedication, devotion, or whatever you can call it, on that. Signals are down again. I'm sorry to say, 00 video and 00 audio. It happens. Some signal comes, but now FPS goes, frame per second goes. So I am also dependent on Airtel, on services of these professionals. Of course, I can call them professionals or group of professionals who operate these services, but I am unsatisfied with their services because there is no continuity, there is no uniformity of signals, there is no regularity of signals. So much flexibility exists, I can't imagine. Then what sort of engineering is this? You have to understand. As an example, within 5 or 4 seconds, 10 seconds, these change very rapidly. Sometimes goes to high, or sometimes below or 0, which is a bad practice, you can say. So there's no quality existence in these services. Now we're talking of communication coordination, which is very significant word without which cannot move. So we can say that I cannot all time depend on one file. And I also close the certificate of fellow, and I'm on quality file, and I go to another file. I open another file, just a minute please, and that is section 5 concrete specifications that were used in state of Qatar, and I am interested in those specifications because those are little descriptive, and you can say concrete is very important part. Browsing this file and reaching somewhere, I don't know which place. Let us say I reach somewhere. There's ready mix concrete. I think ready mix concrete. We had gone through also that. Then concrete plant inspection checklist, we had gone through that as well. That was interesting one. Pumped concrete we are talking about. I think transportation. Let us say transportation and placing of concrete. We are somewhere here. Let's see which next one is transportation. pumped concrete, placing concrete, preparation, placing, and steps in concrete sector, and then we can say we have air concrete formwork. So let us go back to transportation. Though we talked on this, but it's back on, I think maybe 2 days back, because yesterday air and so far it is working. I don't know how long shall it work, but okay, no problem. Let us think of transportation placing a fast, very fast, and see how it works. Again, signals are 00. Unfortunately, maybe my voice not being recorded. Video is 00, audio is 00. It comes again something, frames are back to 0. So what is the concrete transportation placing? There are some pages in this, and what says scope of work. It says transportation and placing of concrete. Transportation and placing are very important, because transport means to carry concrete through some vehicle from batching plant to site, and then from site location to place of where concrete is to be placed. That member. Transportation is from batching plant, or from location where concrete is mixed. Maybe it is on site itself. It from there, when the concrete is mixed and poured into that vehicle, you call it transit mixer, and also you can call dumper, or you may whatever you call it. From there it is driven to site location, and from that site location it is taken to place. It is further transported to place where it is to be laid or to be poured. So in this there is a scope of work. References are given, submittals are required. Then in transportation we can say general, it is general, or it is pumped concrete. Then it is records how to place concrete. General preparation, placing and compaction, continuity of concrete work. And of course we can say transportation and placing of concrete. Transportation and placing of concrete, in that case we can say scope of work. This deals with transportation, placing, and compaction of concrete. There are references like guide for measuring, mixing, transporting, placing concrete, specification for ready mix concrete, concrete complementary, and then there is standard, and of course concrete specification, performance, production, and conformity, Eurocode to design of concrete structures, general rules and rules for buildings. And then there are submittals, of course, very important part of construction or contracting or engineering. Should contractor propose to use concrete comps, etc., they must take permission, and this is a method statement that is required for every major pole, and that statement must contain all these: plan rate of placing, number of batching plants, number of trucks, number of positioning of pumps, power sequence, quality controls, spare equipment, other factors that might affect placing of concrete. This method statement should be submitted at least 3 days in advance of the activity. If required by engineer, the party report planning meeting may be done along with ready mix supplier, contractor, engineer, whatever specifications or requirements of works as rapidly as possible by methods which prevent segregation or drying out, and ensure the concrete is of required workability. Concrete is of required workability, you can say. And you can say if segregation occurs, in that case material shall be remixed to satisfaction of engineer, or otherwise it be discarded. Now, furthermore, cause of segregation shall be determined and occurrence is prevented as such. Contractor shall ensure the time between placing of different lifts or layers of concrete is short enough, not long enough, to prevent formation of cold joints. Contractor ensures that There's backup plant available that can be used in event of breakdown of working plant. Right, in an approved type of truck, mixer or agitator, which agitator truck, which apart from cab and chassis, be painted white and kept clean all time. Again same problem of signals. No use of talking because signals are zero, frames are zero. I don't know why to stop, where to stop. Can say and kept clean. That vehicle of cab and chassis shall be painted white and kept clean all times. Discharge chute and other dirty areas where concrete passes through elements. If shrink mixing is approved by an engineer, then volume be 63% of drum volume. All trucks shall be rotated at 30 revolutions before discharging concrete to assure uniformity. Insides of concrete trucks shall be inspected periodically. Insides of concrete trucks shall be inspected periodically, and whatever build-up of concrete removed that may impair efficiency of mixing action. All trucks be certified either by an discharge of concrete should be completed within 90 minutes or before drum has drum has revolved 300 times. Whatever is earlier. After introduction of mixing water to cement and aggregate, or introduction of cement to aggregates. Limitations are permitted to be waived by purchaser if concrete is of such slump or slump flow after 90 minute times or 300 revolution limit has been reached that it can be placed. It's understood that we can place it well without addition of any to quick shifting of concrete. A time less than 90 minutes is permitted. Practical aspects we are talking of, just like we say 90 minutes, it's important, 1.5 hours, but that varies depending on supplementary cements including in that. But 300 RPM is something very important. So maybe who counts and who records, nobody cares. But we have to learn. If it is possible, if we are smart enough, we have to take care of quality controls, we have to take care of that. It's very important for everyone involved in construction, from every department on site, including quality, construction, consultant, and everyone. If third party is also involved, everybody should think about this. So it doesn't make a difference, but it is important for controls. Better controls means better quality. Mixers are very big bodies, these are not ordinary trucks, and these keep revolving even when they are transported from batching plant to site. It may sometimes be many kilometers away from these batching plants are located many kilometers away from sites. Sometimes it takes half an hour, 30 minutes, sometimes it takes 45 minutes, or sometimes it may take more time. To cover that, some admixtures are also added so that concrete doesn't set on way. And then we have to station it somewhere on site after testing is done and after setting, along with equipment of pouring or placing. It may be crane, mobile crane, it may be tower crane, or it may be concrete pump. And up to time when application of pouring is done, and of course application of compaction is done, and it's properly leveled and finished. Up to that time, this 90 minutes or whatever other times given, sometimes more, and all these values of slump to be controlled, means there are so many factors that one should take care of. People do it, they say we have done it, but sometimes problems come in, and it's very important to understand these points. Experienced people understand them, but sometimes they also ignore. That's also a fact. We have to understand problems, site issues. More and more research is done, more and more experience is done. We cannot be always online as was done in past. Maybe some material comes, new technologies come, supplementary cements are added, cementing metals are added. For example, we add PFA, we add GGBS and microsilica. Likewise, properties of concrete, fresh concrete are varied, and that may affect your concrete or your placing. There are so many ways we have to understand. It's the work of patience, it's the work of intellectual analysis. It's not simply that we read and do. Then accordingly we have to chart out method statements of how to do that. As we said, we have to do complete plan, of course plan for particular activity, because it involves a lot of cubic meter of concrete, and you can say it costs hundreds of work hours, and that means involvement of workers, skilled workers, and also expert machines, or you can say customized machines or equipment you use. So it's a question of complete study. It's a question of, getting quality is very hard work, very smart work, or a work based on concentration. It is not that difficult, of course, but it requires concentration to convert a good design to a good construction product. It's very difficult job, because in designs you have to concentrate in your office, but in sites you have to take care of material, equipment, workforce, and all documents, and then you have to instruct them. It takes, you have to concentrate on everything along with all day-to-day hodgepodge work. Now pumped concrete is something very interesting, because it's nothing new, though you can say it's nothing new. It's very old technology, pumped concrete, and still it is an updated technology. It's a smart technology, because we have to use pump. And what is pump? It's a reciprocating machine. We know it's not centrifugal pump. I have seen two types of pumps. One are stationed and reciprocating pump, where we cannot control boom movement. You can just take your pump to site, fix it, and then run a pipeline onto that location, and then change that location for every batch if it is required. And generally it is called a stationary pump, but it is with customized pump line fixing on sites. It is very old one. We used this one long back when I was in 1982. I still remember 82, you think. 82 I'm talking, 18 years plus 21 years, 39 years back I'm talking of. Still I have seen these pumps are used in our country. No problem, it is machine, but there's another one, we call it mobile pump. It's like, a crane, mobile pump. It carries same boom but with rotating control where you can say operator of that pump can control it, and it takes concrete to it. It takes concrete through it reciprocating pump machine to every location on site, and these pumps are of various types depending on boom length, or you can say coverage. These can be this can reach up to many stories very conveniently. I've seen even up to 10 story, 15 story these pumps can reach conveniently, of course, depending on capacity of pump. So it is an interesting one, you can say, and we call it pumped concrete. And access for pump shall be checked prior to pour. Access is very important. There can be, you can install 2 pumps, you can install 3 pumps, or a number of pumps depending on quantity of concrete as well as size of structure that you are going to pour. This depends on, and that's why it's also stressed that method statement of a particular activity must be planned well. Advanced discussion must be done among all team members, among contracting team, among ready-mix suppliers representative, and of course consultant or supervisor. All should decide what is best way, if it is a very major pour, and how to do it continuously without any break, how to do it maintain speed of pouring if there is enough supply of concrete from batching plant. Batching plant can give supplies, let us say 100 cubic meter per hour. It's not a miracle. It can be more. Generally 35 cubic meter per hour is given by an ordinary central mixing plant. And if we have installed 2 or 3 or 4 mixing machines there, we can get more and more quantity depending on supply, depending on requirement. Many, you can say, big rafts are poured, big members are poured, where hundreds and thousands of cubic meter of concrete involved. And this remains continuous. We cannot break it, even though it may take 2 days, 3 days, 4 days for concreting. It goes on and on without a break of even a single minute. And work goes on like that. And then temperature controls are conducted. Sometimes, temperatures, temperatures controls are involved in concrete itself, depending on depth of concrete, or we can say what type of concrete it is, a massive block concrete or massive foundation it is, or big slab it is. So it depends on that. So many technical considerations we have to look into. You have to plan well. It's a kind of well-studied, thorough study. Means you have to achieve quality. And quality cannot be seen, it cannot be measured, it has to be achieved only. And it depends on concentration, it depends on your continuity of supervision, it depends on the continued total study of subject. And how to do that from time to time, because you cannot plan for a few weeks, you have to plan for a few hours. And within that hours means how active one should be, how active activity should be fast, how activity people should work, and how best machines are controlled, and how best batching plant can deliver that material. Depends. It depends on that. This means total approach is required. It's very rapid work, it's very smart work, it's very dynamic work. Pumping of concrete. Access for pump shall be checked prior to pour. If access cannot be assured, contractor shall not continue concrete operation. Pump concrete is approved, of course, and approval can be achieved, can be obtained, and contractor has to ensure that shock is not transferred from pipeline of formwork to formwork, and prevention laid concrete is a very important point. If approval is obtained for ready-mix concrete, contractor has to use pump and obtain and get, you can say, well-placed concrete, provided all precautions are applied. Precautions in a sense that vibration of pump through pipeline or through its boom cannot be transferred to formwork or to steel. That care we have to take, and it should not impact on previously laid concrete. Or precise specifications, but I am also speaking from my own thoughts, what should be done because of experience. Everything, everything cannot be excluded in writing, it can be included in writing, particularly in this type of specifications, because it's like a book, you can say. You can write a book on concrete, but it's experience that tells us what to do. Concrete is very expensive item and its quantities are voluminous on projects, and concrete is very, you can say, if it is laid properly, in compliance to specifications, it's very good material. It can make life, it change lives of people. And same material can become stone only without having in that parameter, that performance capacity, if it's not done qualitatively. So don't look at quantity only what we have done, but look at quantity, that is quality. Quality based quantity means quality should be an integrated part, is an inseparable integrated part of that material. And that's why so many points are considered, and to do that, every engineer, every engineering student, every engineer working in field, every contractor must know about what is required. It's not just pouring or mixing, as you see in many buildings here around. All quality-less activities go on, and they never mind it. They never mind it because they don't want to know, but they don't know it. They don't know what is concrete. It's only mixing for them, just to mix sand aggregates and coarse aggregate and cement, and that's it for them, nothing else. Temperature control, hours control, this control, that control, nobody bothers. During placing concrete by pump, end of hose, and that is boom, must never reach into concrete. It should not touch concrete, it should be little off that. All measures should be taken to avoid blockage of delivery hose system. That system, that pipe, that boom should not be blocked. Compaction of concrete must be carried out per standard procedure requirements. Compaction of concrete means densifying it to maximum. That is compaction. It can be done by internal vibrator, where nozzle goes into concrete material and releases all air bubbles so that concrete settles to maximum density that it can achieve. We cannot measure it that time, but we say bubbles have stopped coming, it's coming out, so it is compacted. Compaction of concrete shall be carried out per standard practice. It's a matter of experience of that person who supervises it, as well as that person who uses vibrator, and those who know. Concrete gang is expert one, must be very experienced because it depends on different slumps. Sometimes it is too stiff material, and sometimes it's like a fluid, which depends on which material you are going to pour. It's different case. One should identify what's required, and it can be seen from appearance of mix, delivered mix, which is meant for beams or which one is meant for columns. Experienced supervisors, experienced workers can understand that very easily. Grout shall be pumped through concrete pump. Now, when we start concrete, we have to think about that we pump grout. For initial lubrication of pumping system as well as your place where you have to pump. So you just do it, grout and lubricate it. And whatever is charged, maybe 0.25 cubic meter or less, or you can say less than initial discharge of whatever pumped concrete, cannot be incorporated into permanent work because it is not that uniform. So you may say very little quantity of concrete can be discarded when you start pumping. Where concrete is conveyed by shooting or chutes, you can say, or pumping plant shall be of a size and designed to ensure continuous flow in chute or pipe. The slope of chute or pressure of pump shall allow concrete to flow without use of any water, any additional water. And without getting any segregation of ingredients. When we call segregation or we call aggregation, there are two ways. Segregation is reverse of aggregation. When aggregates are combined together, it is, you can say, mixing. You can say that's mixing. Aggregate itself is a word like that. When you segregate, and these, say, concrete gravels are there, stones are there, sand is there, they are separated. Even slurry goes out, and you can say it is segregated. It means mix has gone out of mix. There's no meaning that mix doesn't exist, you can say that. Mix doesn't exist, that's called segregation. And without segregation, we are saying there should be no segregation. Stones, chips, of course, cement is there, which is cementing material for both aggregates, fine aggregate, that is called the cement, and coarse aggregate, that stone. Both are mixed together for connection. For that connection, permanent connection is done by use of cement and water. Cement and water which form which produce, you can say, slurry, or you can say gel, and that gel when solidifies, it combines permanently these ingredients. Delivery end of chute or pipe shall be thoroughly flushed. Delivery end, when concrete is dropped onto a member, that end of chute or pipe is called delivery end. Delivery end of chute or pipe must be thoroughly flushed using water before and after each working period, and it should be kept clean. Water used for this purpose shall be discharged outside pour area and any controls are required, and these are done. And of course, within 24 hours of delivery, these documents, you can say, contractor shall provide engineer with delivery notes, we call them delivery notes, giving information about what concrete was delivered. We have to then scrutinize them, check them at time of receiving itself on site. We have to check what time it is start from batching plant, what time did it reach the site, how many minutes it has taken, and then what is value of slump in batching plant. Then we have to see what is the value of slump on site itself. We take out some concrete and we collect it in wheelbarrow, and then we conduct test of slump, and we also test temperature there, weather temperature and concrete temperature, and also we take air voids in that, we check them. So there are some checks that are conducted for every delivery. It's not that we have to conduct at random. No, it's every delivery. For every delivery, you have to check slump, temperature, air voids. These are minimum requirements. And then we can give clearance to that truck. Okay, you go to location and pour it through whatever pump or crane or tower crane, That is general principle, and this is shown on your you can say records in concrete. It will maintain on dockets itself, or information is transferred what grade of concrete it is, what are admixtures in that, whether PFA is used or GGAB is used, or multiple uses used, or you can say triple or double, you can say that one, or silica fumes or micro silica are used. All these are indicated on that. Likewise, you say as much information you can give, you should give. Is for purpose of record, because record must be very clear, must be definite, certain, and true to what happened. It cannot be fabricated. If we fabricate, we cheat ourselves. Means we are talking, we are concentrating, we are deliberating on quality system, and quality system is quality of materials. A concrete system, rather we call it. Concrete is very wide system, very specific system. People don't call it system, just call it material, but I call it. It's big technology. It cannot be just understood by a few sentences. So placing concrete then comes in. Placing concrete is very important factor. Placing concrete means where? Placing into member for which, on which member of which you are pouring, means it can be foundation, it can be blinding concrete before foundation, it can be, you can say, step columns, or it can be raft foundation, it can be piling, it can also be grade beam or grade slab or plinth beam. These can be columns, and these can be beams and slabs. These can be shear walls, whatever you can say. Concrete is to be poured, to be placed in whole structure. There are various methods for each element, and we have discussed and passed through various method statements. Of course, we can say placing concrete is, of course, not only receiving, but placing is very important. You have to understand and devise a system for itself. Otherwise, we don't stay rightly. We can't get what is quality, which is required everywhere and in every activity in life. And of course, in engineering, life is engineering based, which means that engineering is domain of super life, and profession like medical is domain of super profession. So I'm just trying to remind you why I'm talking this, and we have to see placing concrete is very important item. You can say this is end result of our designs. Placing concrete once done, if it is done, means you have created material that has to be used for coming decades. It is not putting some sheet plate and bolting it or screwing it. It is concrete which makes its own strength to stay forever. Forever, I mean more than 100 years it is possible. Placing of concrete is permanent. It is something if you place on road or on flyover, it depends on which structure you place concrete for. If it's for long term to come, 50 to 100 years or more, you have created something that would stay there for those years going to come. Means you are doing something for many decades to come. Therefore, it imports high degree of significance. An engineer must realize this fact. And once concrete is laid, you cannot it's very important point to understand. And that's why highest degree of care must be taken for concrete pour. You cannot believe in saying, okay, supervisor will take care of it. My workers would take care of it, a firm will take care of it. Just that should not be thought of. Contractor shall obtain approval of engineer to its proposal. All placing and compacting concrete shall be carried out under direct supervision of a competent member of contractor staff with a minimum of 5 years experience in concreting work and in a manner to produce a watertight concrete of maximum density and strength. Maximum density and strength. Nobody can claim what shall be result of that concrete poured, but it does. For night concreting operations, contractor shall arrange adequate suitable lighting for illumination and also from visibility point of view and from safety point of view. Contractor shall provide safe, secure access for all personnel on concrete operations, engaged on concrete operations from all parties involved. Provide safe access, safe, secure access for all personnel on concrete operations. Where thickness of concrete section exceeds 600 mm. 600 mm. If it exceeds that, if thickness of concrete exceeds that, contractor shall adopt special precautions, special measures which are going to be approved, which engineers have to approve, or engineer would amend and approve, or whatever you can say, to avoid thermal cracking due to external and core temperature differentials. Avoid thermal cracking of concrete due to external and core temperature differentials. We studied differences of temperatures, and then this should be avoided if these are excessive. Thermal cracking is not acceptable. It has to be avoided. It's not only surface cracks when talking, it's within concrete itself, which we cannot see using our eyes, and maybe we have to apply X-rays for that. But that's not practical, it's not done like that. Therefore, we have to avoid these cracks rather than taking measures on them. Formation, post-formation. You can say, where thickness of concrete section exceeds 600 mm, contractor shall adopt special precautionary measures to be approved by engineers to avoid thermal cracking due to external and core temperature differentials. And we have already discussed supplementary cementing materials for this purpose. Because when cement is replaced to some extent, let us say 25% to 50% or 25% only, by supplementing cementing material like PFA, PFA fly ash and pulverized fly ash, and also ground granulated blast furnace slag or micro silica fumes. These are used for this purpose, because if you use only OPC or SRC as we used in the past, it's not possible to avoid crack formation. Crack formation can be achieved by delaying early setting time of concrete. And that's the important point here. Purpose of cementing material, supplementary cementing material, is basically that one you have to, in initial stages, generation of heat is lesser. It's not very fast, but let us say after 1 week, 2 weeks, you shall get same strength as you get in OPC by including SCMs on concrete mix. Concrete shall not be placed in adverse weather conditions such as dust storm or heavy rain, because rain can change all concrete work. It can damage it can increase water contents, and we can say it's not in interest of engineer to do concrete work. We said that cracks are very important. Indeed, sometimes we do not know why it's happening, but it happens. But I also experienced that when you use these materials, which are common now, common, and every designer, every executive on site, they must understand meaning of these materials clearly, because without understanding of these materials and without understanding what is concrete, massive concrete block, and what are actual requirements, what should be, keeping abreast all factors of designs and durability, work is done. It is to be devised accordingly. And of course, we don't use adverse conditions, because adverse conditions stay only a couple of hours. Very many methods are there. We have gone through some, which will go through more also. We cannot depend only on specifications, because in specifications are guide only, but based on experience we can think how to simplify construction work, how to simplify concreting work so that it is safe as well as functional. And purpose of concreting is we have to prepare for concrete, and that preparatory work we call preparatory work means form work and steel rebars and pouring also. So we can say preparation is that. Upon which concrete is to be placed. Formwork and reinforcing steel we call it. Contractor gives engineer at least 24 hours notice to enable this inspection to be carried out. 24 hours are enough, but sometimes before also 24 to 80, 48 hours were given for major pours, whereas 24 hours were given only for all items on contract. Means this is not hard and fast rule. It depends on site organization and what value they give to others. Others here means consultant or resident engineer, you can say. We have to see that point. So what time we have to allow for inspection? It depends on site cooperation, site use, priority of material, priority of working. And if concrete is not placed after inspection, let us say for 24 hours, if concrete is not placed within 24 hours, once approval is given by engineer, this approval shall be automatically rejected if concrete is not poured in 24 hours. And of course then re-inspection could be done, or at least that supervisor or that engineer has to come to site to see what's going on, and then it's okay, you can say. We have to inspect, every activity, every work, and the inspection shall be made immediately prior to concreting back, check and clearness and form once you have lapsed 24 hours or more. So that is, you can say, reach. And we also say that, we say that wood forms, unless timed, we use wood, or we can say wood formwork, we use wood material, and if it's lined, it's fine. Or you can say otherwise, you have to oil it, or you can use water for wetting in advance of placing concrete, which is generally done hot weather conditions, and also if there are joints, then in a little shallow water in advance of placing concrete, so the joints tighten. If there is no lining on them, joints tighten and prevent seepage of grout, cement grout from mix. Reinforcement be sprayed, reinforcement in hot weather condition It's placed, we have to cool it. We have to cool it. We have to reduce temperature of steel so that temperature of steel and temperature of concrete, which are different one, they do not fall in same range. And they have to be brought to same range. So you can say wood form until lines shall be oiled and wetted with water in advance of placing concrete so that joints won't tighten and prevent seepage of cement grout from mix. And reinforcement shall be spread with water, small amount of water, prior to starting pour. Reinforcement shall be secured well in its position, inspected and, of course, accepted by engineer before placing of concrete. All inserts, anchor bolts, sleeves, all inserts, anchor bolts, sleeves, and other embedded items shall be accurately located using templates where appropriate and held securely to prevent displacement during placing of concrete. Aluminum items shall be completely covered and protected when embedded in concrete. Attached to concrete by short fixing or drilling without acceptance by engineer. Notwithstanding any such authorization, contractor shall be responsible for all damages that would be caused to concrete and make all such damages good at contractor's expense. Water has, when we talk concrete, talk general, say water shall be removed from excavations. Water shall be removed from excavations, pits you can say, before concrete is deposited or laid. Whatever flow of water shall be diverted through proper side drains and removed without washing over freshly deposited concrete. All the watering works shall be continued as long as required hardened concrete, debris and foreign materials shall be removed from interior of margins. You can say, what I said, water shall be removed from excavations before concrete is deposited. Flow of water shall be diverted through proper side drains and removed without washing over freshly deposited concrete. The watering work shall be continued as long as required. Hardened concrete hardened concrete debris and foreign materials shall be removed from interior of forms and from inner surfaces of mix and conveying equipment. Runway equipment to convey concrete to point of deposits, and these runways are those means for small runways, small planks you can put on walking area onto slab position or wherever you work. These runways or other means accepted by engineers shall be provided for wheeled equipment to convey concrete to point of deposit. Equipment used to deposit concrete shall not be wheeled over in reinforcement, nor shall runways be supported on reinforcement. This is very important item. We have to be very careful while designing such routes on particularly on slabs. that durable basis must be done which do not harm your steel, and that is where common sense applies. No details can be shown on drawings as such, because this is experience, and experience is fertile, it's not futile. It's concrete based experience, it is, pragmatism. How do you save equipment? How do you protect your reinforcement? How to do best work, because this is all part of good quality procedures, and that's where we have to consider, to understand. So we can say runways or other means accepted by engineer shall be provided for wheeled equipment to convey concrete or transport concrete to point of actual deposit. Equipment used to deposit concrete shall not be wheeled or reinforcement, nor shall runways be supported on reinforcement. Before depositing new concrete on or against concrete that has set, existing surfaces shall be thoroughly roughened or hacked, or you can say scabbled and cleaned of latent. No latent should be seen, no latent should be available for concrete to be placed on that. Foreign matter and loose particles whatsoever forms shall be retightened and existing surfaces slushed with a grout coat of mortar consisting of cement and fine aggregate in same proportion in acid mix, but not leaner than 1 to 2, 1 part of cement, 2 parts fine aggregate, after existing surface has been moistened. Existing surface has been moistened. After that, you shall use that, you can say, mix of cement and sand. You can say part cement to 2 parts of sand. Generally people use only slurry on that, cement slurry, but if some sand, fine sand is used, better. No problem, you can use cement slurry also. Grout has attained final strength. Before grout has attained final initial set, you can say. Horizontal construction joints. Horizontal construction joints shall be given a brush coat of grout consisting of cement and fine aggregate in same proportion as concrete to be placed, followed by approximately 75 mm of concrete of regular mix, except that proportion of coarse aggregate shall be reduced 50%. So this is a very important point if you do some new concrete on old concrete connection. So you can say again, I read this point: horizontal construction joints shall be given a brush coat of grout consisting of cement and fine aggregate in same proportion as concrete to be placed, followed by approximately 75 mm of concrete of regular mix, except that proportion of coarse aggregate shall be reduced 50%. High strength grout for precision support of machine base and sole plate. High strength grout for precision support of machine bases and sole plates, including equipment subject to thermal movement, tanks, columns, base plates, seats, bridge seats, anchor poles, and dowels shall all be non-shrink, ready to use fluid precision grout material. Right? It shall be high strength grout for precision support of machine base and sole plates, including Equipment subject to thermal movement, tanks, columns, base plates, bridge seats, anchor bolts and dowels shall be non-shrink. That's what high strength grout it is. Non-shrink grout. It should be. Non-shrink means it doesn't shrink, means no cracks. And it should be ready to use. Fluid precision grout material proportioned, premixed and packaged at factory, delivered to job site to be placed with only addition of water, formwork and curing be specified. One is high strength grout. It can be cement based or it can be epoxy based. Generally, cement based grout is used for stationary, for grouting of, you can say, supports, grouting of, you can say, machine bases or sole plates, where you can say stationary vessels are used, stationary vessels are installed, and where it's compressor foundation, for example, or some other vibratory machine. In that case, epoxy base grout is important. So we have cement, we call it cementitious grout, and we call it epoxy based grout. It is better to use epoxy based grouts for vibration machines and cement is grout for ordinary machines. But there should be no cracking, that is important. So we can say high strength grout for precision supports should be done like that. Its grouting is important because it's a feature of machine that involved in. Now placing. Placing is of course very significant concrete work. It depends on, or you can say it's most important after delivery. Up to now we talked of delivery. We talked of mix. We talked of so many activities for permanent work, for temporary work, for preparatory work, and about quality procedures involved therewith. We are saying concrete shall be placed in its final position. We cannot say this is only temporary one, I'll shift it. First of all, this is not acceptable because concrete has to be placed in its final position before its initial set starts or commences. And it would mixing together for many minutes or you can say for few hours. Concrete shall be placed in its final position before its initial set has commenced and it shall not be subsequently disturbed. All concrete has to be placed within 15 minutes of its delivery or discharge, which directly received from plant to site, or we have to use rotating, agitated, you can say, agitators, those machines. All concrete shall be placed within 15 minutes of mixing unless carefully placed in horizontal layers. That's important point again and again say. Again and again same thing comes in. Concrete shall be carefully placed in horizontal layers which shall be kept at an even height throughout work. Even height throughout work. The depth of layers and time between placement of layers should be such each layer can be properly merged into preceding layer before initial set is affected. Depth of layer should be determined by type of plant contractor proposes to use. Can be said again. Concrete to be carefully placed in horizontal layers and even height throughout work. Depth of layer and time between two layers or between placement of layers to be such that each layer can be properly merged into preceding layer before initial set takes place or affects. Depth of layer shall be determined from type of plant and contractor proposes to use. Generally, concrete vibrator is used for this purpose. Concrete vibrator, which is also a variant. I mean to say concrete vibrates tools. You can say likewise we are talking of. Now we take use vibrator, nozzle and needle vibrator, which goes into concrete mass and densifies it by its compaction method. And once it is done under required controls, we cannot withdraw back concrete from that place. No way out. It rarely happens due to various reasons. Again, signals are down. I don't know what to do with this happening here. Every time I keep on eyes in between while talking to you, because if signals drop, my voice won't be recorded, and if FPS stops, these pages won't be recorded. Well, I am helpless now. Concrete placed in, you can say, concrete shall be allowed to slide. Concrete shall be allowed to slide. It shall be allowed to slide or flow down sloping surfaces directly into its final position from skips, downpipes or other placing machines or devices. Or if this is not practical, it should be shoveled into position, care being taken to avoid separation of constituent materials. Interesting point, how to pour it, what can be done, all that. Concrete shall be allowed to slide or flow down, slide down or flow down sloping surfaces. Of course, sloping surface, chute is slope. On sloping surfaces directly into its final position from skips, downpipes or other placing machines or devices. Or if this is not practical, it should be shoveled into position where care being taken to avoid separation of constituent materials, or you can say where segregation is not impaired with. Segregation is not allowed. Again I say segregation is not allowed. It's not acceptable. You can do whatever way, you can go and see some site how concrete does, but here there is nothing as such from safety point of view. Concrete shall be allowed to slide down or flow down sloping surfaces directly into its final position from skips, downpipes or other placing machines or devices. Or if this is not practical, it should be shoveled into position. Care being taken to avoid separation of constituent materials, or you can say segregation of aggregates. Concrete placed in horizontal slabs from barrows or other tipping vehicle be tipped into face of previously placed concrete. Concrete placed in horizontal slabs using barrows or other tipping vehicles shall be tipped into fair face of previously placed concrete. Concrete placed in horizontal slabs from barrows or other tipping vehicles shall be tipped into face of previously placed concrete. Dropped vertically. It shall not strike formwork between point of discharge and its final place of work, except by approval of engineer. It shall not be dropped freely through a height greater than 1.5 meter. Let's say concrete dropped into place shall be dropped vertically. We have seen that. It shall not strike formwork at any time when discharged between point of discharge and its final place in work, and except by approval by engineer or of engineer, it should not be dropped freely through height greater than 1.5 meters. So concrete dropped into formwork, you can say concrete dropped into place shall be dropped vertically. It shall not strike formwork between point of discharge and its final place of work, and except by approval of an engineer, it shall not be dropped freely through a height greater than 1.5 meter. Chutes and conveyor belts shall be also designed. Chutes and conveyor belt shall be also designed, you can say, so that there is no segregation, there happens no segregation or loss of mortar, and a vertical tapered down pipe or other device to ensure that concrete is discharged vertically into place. Standing water in formwork. Concrete that has attained its initial set of the concrete has attained its initial set or has contained its water contents for more than 1.5 hours or 300 drum revolutions, which comes first, shall not be deposited in work. Concrete that has attained its initial set or has contained its water content for more than 1.5 hours or 300 drum revolution, whichever comes first, shall not be deposited in work. Cold weather concreting shall be in accordance with CIRA Report 67, ACI 306, or ES 1992-11. Hot weather concreting shall be in accordance with Part to protect new concrete from harmful effects of drying winds. Special care must be taken to protect new concrete from harmful effects of drying winds. During wet weather, concrete shall be adequately protected as soon as it remains in position, it comes back to position. No concrete shall be done, shall be carried out during periods of continuous heavy rain, unless it is completely covered during mixing, transporting and placing. No concrete shall be carried out during period of continuous heavy rain, unless it is relevant. So special care shall be taken to protect concrete from harmful effect of drying winds during hot weather conditions. One concrete shall be adequately protected as soon as it is positioned. During wet weather conditions, during wet weather, concrete shall be adequately protected as soon as it is in position. It is there in position. No concrete shall be carried out during period of continuous heavy rain, unless it is completely covered during mixing, transporting. Unreinforced component pedestals will say. Placing being affected exclusively with stationary trammies, placing be adapted through exclusively with stationary trammies or with a boom with bottom opening watertight boxes, and shall be in accordance with requirements of design or equivalent as accepted. Underwater concrete is placed continuously without interruption. For water depths up to 1 meter, concrete may be placed without trimming. In case of water depth exceeding 1 meter, concrete is to be placed in such a way that it doesn't fall freely through water. Trammies must at all times dip sufficiently far into freshly placed concrete to ensure that concrete emerging from trammie does not come into placing of concrete underwater shall be designed, directed, and engineered. All work connected with placing of concrete in the water shall be designed, directed, and inspected with due regard to local circumstances and purposes. Work shall not proceed until all phases and methods to be used in placing operations have been accepted by engineers. Concrete is very, in fact, interesting item, I should say, rather than complication. It should easy to understand, easy to do if we adopt procedures. And some procedures are like standard systems, and our own records say this is better, this is not better. But something is something, something is something. Stops in concrete. What are stops? You have to understand those points very well. Stops in concrete. Stops. Stops at end of period of work. Stops in concrete. Stops in concrete at end of period of work shall be made only at construction joint locations shown on drawings and/or positions accepted. Where position of construction joints are not indicated on drawings, this may be assumed for estimation purpose to occur at 5-meter intervals in foundations and retaining walls, and at 1/3 to 1/4 of span in slabs and beams, subject to maximum spacing of approximately 9 meters. Very cold. Very cold. I'm feeling cold in my, and I take some tumble, some blanket on me. Otherwise, it's different. It's difficult, I'm feeling shivering actually. Let us see for 5 minutes. I put on my body, and now my legs are free. So legs will go, no problem. Let us see how long, because I'm feeling a little cold, and it's very cold. In fact, it's the month of December, but it's temperature very cold, and it's expected tomorrow it's maybe 4 or 5. Sorry, gentlemen, I'll take my care. Stops in concrete at end of period of work shall be made only at construction joints, locations as shown on drawings or in positions agreed while on site, and such situation arises. Where positions of construction joints are not indicated on drawings, this may be assumed for estimating purposes to occur at 5-meter interval in foundations and retaining walls, and at 1/3 to 1/4 of span and slabs and beams, subject to maximum spacing of approximately 9 meters. So these are not emergency one. That's different. I'm talking of at construction joint location surface of concrete. At construction joint location of surface of completed concrete shall be prepared by spraying by wire brushing, by shall be prepared by spraying, wire brushing or chipping so that it's free from all lateins, scum or loose material, and shows a slightly roughened texture and tips of coarse aggregate exposed. Before continuing concreting, exposed concrete face shall be thoroughly wetted. At construction joint location, surface shall be completely completed. Concrete shall be prepared by spraying, wire brushing or chipping. You may say hacking or scabbling, so that it's free from all latencies and aggregates should be exposed. It's free from all latents, all scum, all loose material, and completely roughened. Its texture is shown, is seen, and you can say completely tips of coarse aggregate exposed. Before continuing concreting, exposed concrete face shall be thoroughly wetted, and you can say slurry applied for or possible grouting can be done if it's required. Otherwise, we can just go ahead. In ground floor slab, where ground bearing construction joints, crack inducer joints, construction joints in ground slab floor slab where ground bearing construction joints, crack inducer joints, contraction joints and expansion joints have to be incorporated into work according to appropriation of requirement. Spacing of concrete joints, spacing of construction joints, crack induced joints, contraction joints or expansion joints in water of joints. Where positions or type of joints are not indicated on drawings. In ground floor slab shall be cast in strips not more than 4 meters wide. Where position or type of joints are not indicated on drawings, in ground floor slab shall be cast in strips not more than 4 meters wide in alternating sequence across width of building. Minimum 3 days shall elapse. Minimum 3 days shall elapse between casting of adjacent strips. Within each strip, crack induced joints shall be provided. Within each strip, crack induced joints shall be provided at not more than 5 meters spacing, and contraction joint shall be provided at not more than 15 meters spacing. Contraction joint at 15 meters spacing and crack induced joint at 5 meters spacing. Across width of building, construction joint shall be provided between adjacent strips with contraction joint at every fourth construction joint. Across width of building, construction joint shall be provided between adjacent strips with contraction joint at every wherever, wherever, wherever necessary and as required by engineer. Water stops of a type acceptable to engineer shall be embedded in concrete, shall be embedded in concrete where necessary and required by engineer. Water stops of a type, water bar you can say, water bar of a type acceptable to engineer shall be embedded in concrete. Water stops should be made of a high quality material which must retain its resilience through service life of structure for double function of movement and sealing. Surface of water stop should be carefully rounded to ensure toughness of joint under heavy water pressure. To ensure a good tightness with or without movement of joints, water stop should be provided with anchor parts. Cross section of water stops should be determined in manufacturers. I repeat, cross section of water stop should be determined in accordance with presumed maximum water pressure and joint movements. Complete works of fixed and welded connections must. It's very important para because of water bar. Must have understanding of this. It's particularly in water retaining structures. It's of very high significance. We cannot go without that. Wherever necessary, I repeat this clause, wherever necessary and as required by engineer, water stops of a type acceptable to engineers shall be embedded in concrete. Water stop should be ensure a good tightness. To ensure a good tightness with or without movement of joints, water stops should be provided with anchor parts. Cross section of water stops should be determined in accordance with presumed maximum water pressure and joint movement. Complete works of fixed and welded connections should be based on Complete works of fixed and welded connections must be carried out strictly in accordance with manufacturer's instructions. We can say the cross section of water stop should be determined in accordance with presumed maximum water pressure and joint moments. Complete works of fixed and welded connections must be carried out strictly Engineers' acceptance shall be obtained by contractor prior to start of work. This is everywhere on casting sequence and layout of joints. Water stuff shall be carefully maintained in position prior to concreting on accurately profiled stop boards to create rigid conditions. Water stuff shall be carefully maintained in position prior to concreting on accurately profiled stop boards to create rigid conditions. Type of water bar to be used shall suit joint water stuff shall be carefully maintained in position prior to concreting on accurately profiled stop boards to create rigid conditions. Type of water bar to be used shall suit joint and purpose according to water bar manufacturer's recommendations. Compaction. Concrete shall be thoroughly compacted. Concrete shall be thoroughly compacted by vibration during operation of placing and thoroughly worked around reinforcement, around embedment fixtures and into corners or formwork to form a solid mass free from voids.